Pascal triangle. How can you use polynomial identity to multiply expressions? In A, I have x cubic plus a cubic, while in the B is x plus a cubic. So if you look here closely, let me write with a different color here. If you look in this expression here, we have the sum of the cubes. The sum of the cubes, we already know it can be expanded by the formula what we have here. The first we write x plus a binomial x plus a, then I can multiply x squared, and here is a minus, goes the first term times the second term, but here I will write a times x, because a is like a coefficient, is a numerical value, while x is a variable, so a I'm putting in the front, plus a squared. So that's how we can expand the sum of the cubes. But on the other hand, here we have the binomial x plus a in a cubic. Even though they look slightly similar, still there is a big difference, because here is a x cubic and here is a cubic, while here is a x plus a, everything is in a cubic. So the result is going to be different, and we can rely in the Pascal triangle here. And because it's the cubic, so I am relying in this line here. And now if I'm expanding this one, that is going to be x cubic. The first, it means the coefficient is 1 in the front, and the first term is going the highest degree, whatever is here is a 3, so I'm writing 3. Because it's the plus, all the signs are going to be positive. This is the same thing if, for example, if I'm multiplying the binomials x plus a times x plus a times x plus a, because all of them are positive. If I'm distributing, the signs are going to be positive. And now, what is going to be the second is the coefficient is a 3, so the second term, the coefficient is a 3, according to this Pascal triangle. And the first term is going to be in the degree less 1 than the degree what is in the previous term. And the second term is going to gain the degree, so it's in degree 1 here. But don't forget, here I could write a in exponent 0, but a in exponent 0 is 1 times x cubic is x cubic. That's why here is a x cubic. And now I'm going in the next term, which is a plus, and I'm looking at coefficient. The third term here is a 3, so I'm writing here 3, and x is going to be 1 less degree than this term here, so it's going to be x in 1. Let me write in 1 here, maybe it's better. And a is going to increase, the second term is going to increase the degree, so a is going to be, it was a1 in the previous term, but now it's going to be square. And the last one is a positive, because everything, as I said, is a positive, and here this coefficient is 1, so I'm not writing 1, because whatever I multiply by 1 I get the same. So here the x is going to be x0, because here is 1, x0 is 1, 1 times 1 is 1, and now this second term is going to gain the exponent, which is going to increase, to increment for 1 more, so it's going to be the exponent in a third. And just let me rearrange a little bit better, so I will write here x cubic, and let me write the variable in the back, 3 times a x squared, so I can write 3 times a x squared here. And the next term I can write plus 3 times a squared times x, 3 times a squared times x, and the last term is plus a cubic. So this is done.